Welcome to The Explainer. Today, we're taking a journey into the vast, hidden world that covers most of our planet. So let's get right into it.
So think about it. When you look out at the ocean, what do you really see? A huge, flat, blue surface, right? But what's actually going on underneath all of that water? Well, it's a world that is way more complex and dramatic than you could probably imagine. Okay, let's kick things off with a big number. 71%. That's how much of our planet's surface is covered by oceans. There's a really good reason we call Earth the blue planet, and we're about to find out just why that blue part is so unbelievably fascinating. Yeah, because it is so much more than just a big pool of water. It's a dynamic, structured, and incredibly varied world with its very own geography and climate. So, you ready? Let's take a dive. All right, first up, our blue planet. Before we go super deep, we gotta look at the big picture and the fundamental engine that drives this whole thing. What you're looking at right here, this is basically the planet's engine room, the hydrological cycle. This constant circulation of water, I'm talking between the oceans, the atmosphere, and the land, it's been working for billions of years, and it's the fundamental reason life can even exist here on Earth. A lot of us probably picture the ocean floor as this huge, flat, sandy desert, right? Well, that could not be more wrong. As this quote really drives home, the land under the ocean is just as varied and rugged, maybe even more so than the continents we all live on. Okay, section 2, the hidden landscape below. All right, let's start our virtual descent. We're going from the coast all the way down deep into the abyss. So as we make our way down, we're going to pass through 4 major zones. We start in the shallow waters of the continental shelf, then we drop off steeply down the continental slope. That leads us out onto the huge, flat deep sea plain, and then finally into the crushing pressure of the oceanic deeps. Okay, so the continental shelf. The main thing to get here is that it's basically just the submerged edge of a continent. And its size, it varies like crazy all around the world. It's almost non-existent off the coast of Chile, but then it's a massive 1,500 kilometers wide in the Arctic. And get this, because it's been collecting sediment from the land for millions of years, it's also where we find a ton of the world's fossil fuels. All right, section 3, underwater mountains and canyons. We're off the shelf now and heading into the really deep ocean. And trust me, this is where the scenery gets absolutely spectacular. And this just shows you the incredible scale of what's hiding down there. The Mid-Oceanic Ridge System is by far the largest mountain range on Earth, and it wraps around the entire globe like the seam on a baseball. This is the heart of plate tectonics, where new ocean floor is literally being born. I mean, it's so massive that parts of it, like the entire country of Iceland, actually stick right out of the water. Then we've got things called seamounts. Just picture it, a standalone mountain, maybe taller than any peak in the Rocky Mountains, but it's completely, totally hidden beneath the waves. The Pacific Ocean alone has thousands of them. It's wild. Now, a guyat is a really interesting type of seamount. It's basically an ancient volcanic island that used to be above the ocean. Over time, waves pounded on it and eroded its peak into a flat top. Then, over millions of years, it sank back down into the deep, leaving this really distinctive tabletop shape. And of course, in those beautiful, warm, tropical waters, you find atolls. Now, these aren't geological formations in the same way. No, these are incredible structures built entirely by tiny living corals growing over thousands and thousands of years on the rim of a sinking volcano to create these gorgeous protective lagoons. I know, it's kind of hard to wrap your head around the sheer scale of all this, right? But to give you some perspective, let's talk about submarine canyons. We are not talking about small ditches here. These are colossal valleys carved into the seafloor. The Hudson Canyon, just off the coast of New York, is actually comparable in scale to the Grand Canyon. Seriously, just let that sink in for a moment. Okay, part 4, the ocean's invisible layers. So we've talked about the solid ground under the water, but the water itself, it's not just one big uniform blob. It's actually structured into these distinct, invisible layers that are defined by temperature and salt. First up, there's something called the thermocline. Think of it like a thermal cliff. You're swimming in the warm, sunlit surface water, and then, bam, you hit this boundary where the temperature just plummets. This invisible wall shapes entire marine ecosystems, and what's crazy is that something like 90% of all ocean water is actually in that super cold, deep zone below this line. And hey, there's a similar boundary for salt, too. It's called the halocline. It's a zone where the salinity, The saltiness of the water increases really sharply as you go deeper. It makes sense, right? Denser, saltier water sinks, creating these layers.
So if you're not in the polar regions, you can pretty much think of the ocean in three distinct temperature layers. You've got that warm top layer, then that quick transition zone, the thermocline, and then the huge, stable, and extremely cold deep layer that goes all the way to the bottom.
So, how salty are we talking? Well, on average, the ocean is about 35 parts per thousand. But as you can see here, that can vary a ton. The Red Sea is saltier because of all the evaporation. But then you have an extreme case like Lake Van in Turkey. At 330 parts per thousand, it's a body of water that's nearly 10 times saltier than the open ocean. Wow.
So why all the differences? Well, it's this constant dance between things that add fresh water, like rain and rivers, and things that take it away, like evaporation. And up in the polar regions, the freezing and thawing of ice plays a huge role in changing how salty the water is locally.
Okay, final section, a world in motion. So we've got this incredible hidden landscape. We've got these invisible layers of temperature and salt, this constant interplay of forces. So what does it all mean? What does it all add up to?
This is really the most important thing to take away from all this. The ocean isn't just some feature on our planet. In many ways, it is our planet's life support system. Its hidden mountains, its layered chemistry, its internal climate zones, these aren't just cool facts. They are all part of the interconnected engine that makes Earth a living, breathing world.
Look, we've really only just scratched the surface of this incredible hidden world, just exploring its basic physical and chemical structures. But understanding this stuff is more important now than ever, and it really makes you wonder, right? As our planet keeps changing, what's next? What does the future hold for this vast, dynamic system that gives us all life?